Hey everybody, next year in geometry you're going to be doing a lot with shapes. One of those shapes is triangles, and you're going to be using Pythagorean theorem to find the missing side of triangles. So just a reminder, Pythagorean theorem is a squared plus b squared equals c squared. So in this setup, a and b are the two sides that are not the hypotenuse, and then c is always the hypotenuse, which is the side across from the 90-degree angle. So in this case, if I set it up, it would look like 3 squared plus 3 squared equals c squared. So 3 squared is 9 plus 9. So 18 equals c squared. So remember, to get rid of the squared, you can take the square root, and that gets rid of the squared. So what we're left with is c equals square root of 18. And I know in the past we did plus or minus, but because it's a side of a triangle, it can only be positive. So we're just going to do positive square root of 18. So we don't know the square root of 18, so we're just going to leave it like that for now. So we know square roots of perfect squares. So like square root of 9 is 3. Square root of 18 though, that's not a perfect square. So that's one that we would need our calculator for. Or today we're going to learn a way to simplify it. So something that's going to help us simplify it is knowing all the perfect squares. So if you don't know all of these perfect squares, maybe take a screenshot of this page or just have a Google list up while you're doing your homework. Quick vocab. This symbol is called a square root, or it's called a radical. So frequently you'll hear me call it a radical. And the number inside of a radical is called the radicand. So the first thing we're going to do with square roots is learn how to simplify them. So we have the square root of 18. We want to do something with it. So we're going to use this multiplication property of square roots. So what that means is if you have two values multiplied together inside of a square root, you can split them up and take the square roots separately. So for example, here we have square root of 18. 18 could be split up into 9 times 2. So with that, I'm going to actually do it this way. So the way I usually write this is, since it's 9 and 2, I could write it as square root of 9 times square root of 2. And square root of 9 is 3. And square root of 2 you can't do, and it doesn't simplify anymore. So we're just left with 3 times the square root of 2. So this idea of taking a square root and then simplifying it is what we're going to do first. So when you're doing this simplifying process, the first thing you want to do is you want to try to find the biggest perfect square that goes into this number. So you want to look at your list and figure out which of these numbers in green go into 24. So as I look down this list, the first number that multiplies into 24 is 4. So I know that's one that I want to use. So it's going to look like square root of 4 times 4 times 6 is 24. And 6 doesn't have any perfect squares inside of it, so we're just going to leave it alone. So square root of 4 is 2, and we're left times square root of 6. With 160, hopefully you can see right away there's a 0 on the end. If I ignore the 0, I'm left with a 16. So 16 is one value inside of this, and 16 times 10 is 160. So square root of 16 is 4, and then 10 has no perfect squares inside of it, so we're just going to leave it as square root of 10. Sometimes it can be a little bit trickier. So for example, 48. Maybe I didn't see right away a perfect square. So I'm like looking down the list and I'm like, I think 4 goes into it. So how I could start is I could say square root of 4 times 12 is 48. The square root of 4 is 2. But 12 actually has a perfect square inside of it. So we're going to split up the square root of 12 into square root of 4 times square root of 3. So what that means is we just didn't find the biggest perfect square in the original problem, so we just have to do a few more steps. So we still have this 2, and then square root of 4 is also 2. So each time, notice I'm carrying things with me. So 2 times 2 is 4. So our final answer is 4 square root of 3. Same with 112. So it might be hard to find my original number that would go into 112. But I know that 112 is an even number. So maybe I'm going to start with saying 2 goes into it, even though 2 is not a perfect square. So I could start with saying square root of 2 times, in my calculator I did 112 divided by 2, and I got 56. So square root of 2 I can't simplify, so it's going to stay square root of 2. And then 56, I'm going to go down my list and try to find what number would go into 56. So I know 25 times 2 is 50, so maybe 16. So if I did 56 divided by 16, nope, that didn't work. I'm actually just going to try something I do know. So I know in 56, that splits into 7 and 8. So I'm going to split this up into square root of 7 times square root of 8. So square root of 7 still can't change, so I'm just going to bring it down to square root of 2 times square root of 7. 8 now, finally we know a perfect square inside of 8, so 4 is inside of 8. So we've got 4 times 2. So really it's a lot easier if I had found the biggest perfect square originally for 112, but this process is just going to take me a little bit longer. So what we've got is we've got square root of 2 times square root of 7. We now know square root of 4 is just 2, and then square root of 2. If I were to combine these together, we know with the multiplication property we can multiply them together. So because these two match, I could multiply those together and turn them into square root of 4 times square root of 7 times 2. Square root of 4 is 2 times square root of 7 times 2. And then because these both do not have square roots, I can also multiply those. So 4 times square root of 7. So that took a really long time. So instead of doing it that way, how I would highly recommend is at the beginning, since we didn't find a perfect square, you want to just keep looking down this list and try to find the perfect square that's going to go in it. So I'm going to try 112 divided by 16. So right away, that is going to work. So we've got square root of 16, and 112 divided by 16 is 7. So 16 is the biggest perfect square that goes into it because 7 has no perfect squares. So we'll be left with square root of 16 is 4 times square root of 7. So that method was a lot faster. So why don't you guys try the practice problems? You're going to try to simplify your radicals as far as you can so that you're left with just a number and then a number inside the square root that has no perfect squares inside of it.